Alright. Welcome to the Game Engine stream number 58, 57? Yeah, I think so. Anyways, today is Thursday. I missed the last two streams. I said I would be off on Tuesday, and then Wednesday I just ended up being off. Took a day off with my girlfriend and everything, so that was nice. And yeah, I guess I'm here for today. So, let's see. Updates and anything. All right, so let's get into the updates. Let me go and switch over to that section. All right, so I've been doing some work in the background. I bought a VPS from Hostinger, and it's a very simple Debian-based server. I did all of that preparation for getting the engine to compile on Linux for this, the VPS, right? So I already bought the VPS, and I am just in the middle of compiling the program on my personal Linux computer. And then I'm going to take that program and just move it over into the, into the VPS and see if it works. And then at that point, I'm going to leave the VPS on, and then I should be able to play Pong from anywhere in the world. Of course, there'll be latency depending on where you're at relative to the server. The server is in North America. But yeah, theoretically, once it's set up, you should be able to play multiplayer online, and it'll just constantly be on, which is really nice. Of course, I still have some issues to deal with the game itself as it currently stands, and I will update it once I fix those issues and finish up my development of Pong, right? But this was a big milestone for me with this, was getting a VPS set up and being able to host the server on an external server, hardware server. So yeah, that's that. And today I'm gonna start working on a particle system. I said I would add a particle system, I believe, when I start working on Breakout. That's 2 games from now. But I don't know if you've seen my last stream, if anyone's seen the last stream, but I just posted on YouTube so people can see. But if you've seen it on Twitch, I was getting very frustrated with the text rendering and the whole UI system as it stands, and I've been working on the UI system for a few weeks now, I believe. So I need a break. I need something else to do. And I was looking online at the Cherno. He had a 1-hour particle system that he did like a few years ago. If I post this video on YouTube, let me switch to another song. When I start talking, I get kind of distracted. Yeah, anyways, he had a 1-hour particle system that he added to his engine, and I want to see if I can get something like that done. And yeah, it'll be really nice to have a basic particle system in the engine. It won't be super performant, it won't be exactly what I probably would want it to be, but it will be in there, and that'll be nice. So I'm expecting this to take a few streams. I've already sort of laid the groundwork with a previous commit, and at the beginning of this stream, I'll kind of just show you how much progress I've made up until this point. And yeah, after I'm done with this particle system, I'm just going to go back to working on the UI, but I just need a little bit of a break. So other than that, let's go ahead and check out the progress board. All right, So yeah, for the progress board, I've been working on tame text rendering. Let me add a little particle system. Yeah, and this seems like it would be like a really big thing, but actually in its most basic case, it's not really that complicated. Particle systems just get complicated once you start really adding a lot of extra like features, and like there's a lot of ways you can go about it. Adding different images, different shapes of quads that you want to add. Billboarding is a whole thing. Still haven't fully grasped how I'm gonna set up billboarding actually. But for now, I'm gonna keep it as more of a simple system, where I'm just gonna use a simple 2D orthographic view, and then after that, I'll start worrying about like more 3D stuff. So yeah, just want to add this in real quick, just as like a fun side project. And yeah, I think from here, I'll just show you where I'm at currently with it. I think I was supposed to recap the previous stream. The previous stream before this, I was working on taming text rendering. And specifically, I was kind of like racking my brain against... What was it? I can't remember, it was a few days ago. Let's look at the commit. Let's look at the commit so I can take a look. So dev. Right, these are kind of a mess, but this was the previous stream. I did a few commits in between. I'll mainly recap this one. This one. Okay, let's start with the previous stream just so we can all be on the same page. Yeah, so the previous stream I was just kind of setting up basically text alignment for separate lines. So basically I want to make sure that I'm able to align a series of lines and all of them have their own alignment, because currently I only have alignment for one line at a time. So I've been adding the infrastructure for treating each line separately and giving it its own metadata so that I can align entire like paragraph to the left, to the right, or into the center, and then each line has its own alignment in the middle, if that makes sense. So that kind of summarizes, and then it took me like 7 hours just to push like I think 100 lines of code because I was just trying to figure out what I was doing. So yeah, I think that was my breaking point. I was like, I need to take a break and come back to this with like a fresh mind. And here I was doing this, this commit was just on my own time. I was trying to work on my commits, or how do I say, I was trying to work on my Linux build, and the compile times were taking forever for the editor, so I just fixed up my includes. I basically got rid of using, where is it? Let me see if I can find Carcona.h, which is like a really big header file that's super bloated. And it's a really good like single include when you have like a very simple like final executable that you're trying to put in. Like the runtime is very simple, so I can just chuck in the Carcona.h and not think about it. But for the editor, the compile times were getting crazy, so I needed to separate them into their own respective headers, right? So that the compile times go faster. So that's all I did here. I just took out Carcona.h and then just included the only actual needed headers for each implementation file in the editor. And you can see here, this is just all in the editor/source. All right, so yeah, this is where I started with a particle system. I wrote kind of the basic framework for it on my own time, because I was trying to like figure out if I could even do it right now. And yeah, I think I will be able to. Again, I will link Cherno's video for this, but maybe I'll just show it real quick. 1 hour particle. Cherno. Yeah, so I'm not gonna show too much just for, how do I say? Wait. I think I do this captcha. Yeah, I'm not gonna show too much just for like DMCA and everything. I don't wanna mess with that. But yeah, let me pause it. But this is basically what I'm going for. This 1 hour particle system is not very performant, but I want to get it in there. Oh, hey, NCB, Happy New Year's, man. Happy New Year's to you too. 2025, huh? How's the new year for you so far? Mine's been kind of sleepy so far. It's going good. Yeah, 2025, right? Hopefully it's a good year. I don't know. I guess we'll see. Right now I was just kind of recapping, how do I say, where I'm currently at. I don't know if you've seen, but the past 20 videos for me have just been like me working on the UI. Maybe 10 videos, I don't know. So I'm trying to take a break from UI right now. I'm working on a little particle system. Try to chuck it into the engine real quick and mess around with it. And I'm going to be using this guy, the Cherno's implementation, as a basis for mine, since his is very simple. And yeah, just get it in there. I promised myself I would dominate the game industry. Dude, dominate it. Hey, give me a little cut too. I'll take some. I'm just working on an engine, so I don't know if I'll be dominating anything very soon. But let's see. Let's see. Yeah, so yeah, I have a, what is it called? I've already kind of laid out the groundwork. I'm going to use his as reference, so let me go ahead and pull his actual Git repository for this. I have it pulled on my Linux build, but I mean on my Linux desktop, but let me pull it here as well, just so I have it. Is it gonna paste or nah? There we go. Yeah, I hope that game that you're working on NCP goes good this year and everything. I don't know what specifically, what specific goals in mind you have with it this year, but I hope you achieve them with it. I remember you were telling me some ideas and how you were gonna go about it. It was the... Was it the online level you were showing me? I'm trying to remember. Yeah. Maybe that was... Yeah, my memory's so bad right now on this. I'm kind of all over the place. Yeah. Alright. So sandbox particle system. Here we go. And let me just check over and make sure. I recap. Okay, so I'm wondering if I should show Cherno's first or if I should show my... I'm gonna show Cherno's first, just so we can take a look at it. So for Cherno's particle system, right, he has an... This is what actually runs his system. He has the particle system. This is the actual like bones of it, and of course he needs to have for random numbers for generating. I believe for his he has like lerps, and then he'll have like random orientations where the particles will move, right? And then to get those random orientations, he uses his own little random thing here. I think he just uses the standard library random function though, but has his own little API for it. So here basically he has an init for the system, and then you just call this static float and it just generates a float for you. And then this just generates like a random generator, or this has a statically assigned random generator. And this distribution describes like what the range is, I guess. Or if you're going from like 0 to 1 or 2 or whatever. Well, I suppose this is the actual range, but you can define the range in the distribution. He kind of does it here, which is interesting. But long and short of it, he's just getting a random float. I believe from 0 to 1 in this case. And let me see what he has in the implementation file. Yeah, so he just defines the actual objects themselves. So this is just implementation stuff. That's nothing too interesting there. And then this is the actual particle system he used. So I already grabbed a bunch of this code. You'll see in a second. But basically, this all kind of revolves around this particle struct and then this vector of particles. And everything else is just surrounding stuff for, like, this is for rendering. And this is like a particle props, which basically he just uses this so he doesn't have to define the entire particle when you make a call to, like, basically add a particle to the system, right? So basically how this runs is you interact with the system, right? You would create a particle system, and then you connect the OnUpdate, so you make sure you need to call this, and then this would handle like updating each particle's like lifetime. So if a particle is supposed to live for a second, this OnUpdate will update that particle's time. I'm gonna do something a little bit differently. I'm not gonna decrement the time step for each individual particle. I'm just going to set like time points, right? And that time point, you don't have to modify it. It's just time just gonna move on like it does, right? And that'll be how I like move through time. If that makes sense. He actually decrements the actual time step for each particle, which is a lot of processing. And then the OnRender, you can guess, just goes through all the particles and renders all the particles. So again, this loops through all of everything in the particle pool and decrements the time and renders each particle at its appropriate location. And then Init just adds a new particle, right? And yeah, this struct just defines what a particle is, right? You have a position, a current velocity, right? So this is in 2D space. Mine's going to be in 3D space just to be more inclusive, I suppose. And that works better with my engine. Color begin, color end. So this is basically a lerp. So he's doing a linear interpolation of the colors between the starting point and then the ending point, and I'll show you how that's done. He just uses a GLM lerp function that's provided by our math library. And I'm probably going to do something similar as well. This is the rotation. Since he's working with 2D, you only need the one rotation. I'll do something very similar. And he does size, begin, end. So in his case, he starts from like a certain size and then ends at a different size. This is just internal lifetime stuff that is a bit different in my implementation. I'll show you. Hey, Sam, how's it going? I wasn't on the past 2 days, so I apologize. But it's nice to see you. Come by. I'm taking a bit of a break right now from the UI stuff I was doing last stream. I'm writing a bit of a particle system, and I'm using the implementation from this guy named the Cherno. When I post the video, I will link to his original video, but he makes a particle system in 1 hour, and I'm just kind of following his. And I've made a particle system before in my own implementation in a separate renderer, so I might take some notes from that as well, but I'm basically using this one as a guide, making it work in my engine. And he has a link to his Git in the description, and basically that's what I'm looking through right now. I downloaded it locally, and we're just kind of like running through it. Ooh. So yeah, basically this struct defines like a particle and then how it's treated in its lifetime, I guess. Again, its position, its velocity, that should be fairly self-explanatory. And then this color begin, color end, and size begin, size end. Size end are just linear interpolations for the lifetime of the particle, right? And then after, I mean, assuming if it's a particle, after it goes past its lifetime, it goes away. It falls off of the particle pool. And then the rest of this is just implementation details, right? So this stuff is just for like rendering, which I have my own way of doing, so I'll get into that for my system. But yeah, Init just adds a particle. This renders all the particles in the particle pool, and this update just updates the time step or the lifetime for each individual particle in the particle pool. And let's take a quick look at this implementation file. basically, yeah, in the OnUpdate, right, that one I described earlier. So he resizes the particle. He does a resize, which is interesting. I would do a. I think he knows that too. I like he talked about it in one of his videos, but I would do a. What is it called? Reserve. Yeah, instead of resize, because this generates 1,000 objects, but reserve doesn't, just opens the capacity. So I would do that instead. Yeah, in the OnUpdate, he just loops through, updates the time remaining for each particle, and then also adjusts the position based on its velocity and the rotation, right? It's interesting. Okay, so it's interesting. He increments the rotation and position each frame, so he kind of has his own physics system kind of going with it. I'm wondering if I want to do something similar. Interesting thing about particle systems is you can go as crazy as you want about this. Like, you can define your own functions. You can, like, for the path and rotation of a particle, you can define like your own equations. And you can even maybe draw like your own little like curves, like you have an X and Y axis and draw your own curve. And then that will kind of define like the path that the particle will take. You can go crazy with this. And then this whole like rendering situation is not super optimal. Mine's gonna be a bit better because I do like batch rendering by default in my renderer. So I'll show you how that works. For him, he's basically going through each particle. Here he's doing some basic like boilerplate setting up like a shader. He does like lazy loading for the shader code, and sets up the shader program and whatnot. Sets up a projection matrix so it can be used internally in the shader. And then throughout here, he loops through each particle and then does his linear interpolations. That's what I was talking about earlier with the color and then the size. And then for each one, he just renders each particle individually. So for me, mine's more of a batch renderer, right? So I'll submit each one individually, and then everything will get rendered in one draw call. So a little bit more performant. I think the ideal case really with these particle systems is you want it to be on the GPU. So you would want, how do I say? Probably like a compute shader to be running this, or you'd want some way where the particles just get, most of this processing can be done in parallel because all the particles are relatively independent of each other. If you're doing a physics simulation, that's a bit different, but it just depends on what you're doing with the particles, I suppose. Yeah, emit. All this one does is just adds a particle in. It takes in the properties and then it generates an actual particle, and then it just at some point adds it into the pool. In this case, he has like an index that I'm assuming he loops through the pool, and then I'm assuming that probably keeps it like cache friendly. I might figure out my own way of doing this. I don't know. Or keeps everything contiguous as much as possible. I don't know. But yeah, I'll think about the data structure myself in a moment. But yeah, that's basically his own little particle system. That's pretty cool. Let's see. So that was Cherno's one. I might come back and reference this a few times if I'm getting lost. I made a commit myself while I was working or whatever. I just wrote some code. And I'll show you that now. This says it didn't compile. I think there was just some like little issue that I resolved in this next commit. This is pretty simple. But yeah, here, yeah, I misspelled groundwork. Basically, the main thing here is I added a particle service, right? Which is basically the same thing as his particle system. In my scripts, this is kind of a nothing burger, I believe. Oh, okay. So I did two things. The first thing I did is I added a proper pseudo random generator for the particles. And give me a sec. I think my cat's sneezing. I'm gonna check on her. Okay, I'm back. So basically here in the scripting service, I already have an implementation of a pseudo random generator, right? I just found one online and just chucked it in here. But I didn't have it like formally included in the engine. It was just only here in my scripting system, right? And I think I use this to define some type of ID generator for the different script IDs, I guess. Yeah, something like that. So I took this out of here and I just defined it more formally instead of random. So if you go to random.h, you can see I added basically a pseudo-random generator and a pseudo-random service. So my general coding practices for my engine is if it's a service, you interact with it. If it's just named generally, typically this is like a class that you would create yourself. And then the service is where you actually interact with like a system, right? So basically you would make your own generator, pseudo-random generator, right? And then you provide it with a seed and in the constructor. And that seed will basically describe like the beginning point of the generator, and then it will internally use its own logic to generate a random number starting from the seed. But this pseudo-random number generator is not as robust as like a normal random number generator. I do have a normal random number generator that I do use, but the pseudo-random generator is more performant. And for random permutations inside of a particle generation, I don't need it to be like super uniform, well-established random numbers. I just need it to look random, right? And this is kind of like the random generation you would think of in like Minecraft, where it's like you put a seed and then it's generating like a world for you. And this is the same thing, right? So you provided a seed, and then basically the state gets incremented over and over again, and then this state describes what random number you're going to get this time. And basically you create a generator with a seed, and then you interact with this service to generate a number. So you provide the generator as a reference, and then it outputs a number. So it's kind of like a C style of like, you would have like a separate area where you have your functions, and then you just define like data here, right? I don't mind these const experts. These are just like part of the way the service works, the actual calculation or whatever. And yeah, you basically have two things. You can either generate a number, or you can reset the state of a generator. So if you reset the state of a generator, it resets this state, and then this seed and the state become the same again, right? So you can re-roll the same stuff basically. And this will give you a random number, a uint64t. I don't have bounds checking for here. Maybe I should add that soon. It just gives you a random like uint64. So anything within that size of a number, you can get something in there. And then if you look at the implementation file, it's basically the same thing as earlier, right? It just generates a random number, updates the state that's provided. This just resets the state to the provided seed. And then when you create a pseudorandom generator, of course, you, how do I say? Set up the seed and the state, right? So yeah, all of this to say that now you can use the pseudo number random generator. So later when I start using that in the particle system, I'm going to be using this. All right, so let's get down into the particle system that I wrote in. So let's take a look at, okay, these are just what I was looking at earlier. Okay, it's just mainly this part. So you can see, again, service, right? This is what you would actually interact with, right? Oh, Kitty, you want to go out? I'll be right back. Okay, I am back. All right, so earlier when I showed you the Chernos code, this particle service is the same thing as his particle system, right? Mine's a bit more simple. I'm gonna roll the render code and the update code into the same function, and then later if I need to like separate them, I'll just do that later. But generally, I just run the OnUpdate and it'll do both the updating the times and everything, and updating whatever it needs to, along with rendering the actual particles. So I can just do that all in one function. How do I say? If I need to separate it later, I will. So yeah. AddParticle, I figured that was more easy for me to remember than Init. So for him, he has like a particles properties thing. I may end up doing that too. But I like just providing the actual particle itself and then just go on from there. And yeah, this will just add the particle to the system, and then this OnUpdate will do all the rendering stuff. So pretty simple API so far. And then this is the particles context, right? So, okay, yeah, and I think this was why it wasn't compiling before, because this particles context, I moved it around. It's not defined here anymore. It's kind of silly. But I have it in my implementation file. So this particles context, basically you have the same particle pool. I didn't change the name of it or anything. And then I have my rendering spec. So this is kind of like his shader code and all that stuff he had. I have all that rolled into this spec. And yeah, you had the OnUpdate. I haven't defined anything yet inside of here, so we're gonna get onto that in a second. And I guess the last thing I need to show is the current state of the particle itself. So instead of a vec2, I have a vec3 for the position and velocity. I have a rotation defined, right? Color start, color end, so size start, size end, and then I'll change this depending on like how I want it to come out or whatever. And then here's the difference for me. So for him, he has a time step that he updates, right? For me, I just have a beginning and ending time, right? And this has like pluses and minuses. So the plus for this is that I don't need to keep updating the time step for every single particle every time I loop through, right? Which to me is cool, right? It's good I don't have to do that. The negative for this is that, say I have a game and I want to stop it, right? Unless I have like a internally defined time or something that I'm like incrementing, time just moves on, right? So it would make pausing difficult for the game, since if time just moves on anyways, then you'll get like weird situations where like maybe the game freezes for a second and the particles, how do I say? Like the time will elapse immediately and all the particles will drop because the time lapsed, but in the game you're still frozen, right? So that's kind of a weird situation, right? So I'll see. I mean, that could be fixed by just having my own personal time instead of using these like chrono high resolution stuff. And then just move the time along myself internally, and then that way I only have to move along one time, and everything else responds to that time being moved along. Or I could just do it the way he does, and just like decrement all the times at the same time. But I'm not a huge fan of that. So we'll see. I'm just gonna go with this for now, and then if I have to change it, I'll change it. But yeah, that pretty much recaps where I'm at right now with that. Let me take a look at this. This was just like a quick fix because this was not compiling. Basically, I just made some changes here in the particle service. I added an init and terminate function. There's nothing in it yet. I just put it there because I usually have an init and terminate function. This is going to need it. I also changed some of the names. I had particle service, I changed to particle. I moved this context into the implementation file. Might move it back, depending on how I feel. I don't know, it's not really that important. And I made it compile again because now this thing is defined, this type is defined, and then, you know, I have it right here in the implementation file. So no more throwing an error, right? That's what was causing the issues with the workflow. Yeah, and then also I think I did some change with Git. That was about it. So when I Git, the README, because for some reason the dev, like I had the dev branch ran twice for the where is it? I can better explain that by just showing you. This little build thing, it had both this dev for some reason in the back end, and I don't know why. So now this one says main, now this one says dev, like for the internal reference. And yeah, that pretty much brings us to right now. Yeah, and I did some of that coding off stream because I was actually intending on just doing it off stream, but I was like, you know what, I'm gonna do it on stream. I'm gonna finish particles on stream. I think it's a pretty fun thing to work on. So yeah, we'll get this done real quick and it'll just be in there. Yeah, so without further ado, let's go ahead and start. Yeah, let's go ahead and start. Oh yeah, I tried to open my project. And also I need to pull the changes really quick because I was working on my Linux build. Ooh. Okay, I think that is good. Let's check my branches, make sure. Yep, that looks like it's right, and I messed up this name. That's me. Alright, we'll go ahead and let this compile. Cargano.h. Yeah, hopefully it's a good new year this year. Let's see. I had some friends message me for New Year's this year. That was really nice. I gotta start hanging out with my friends a little bit more. Maybe that should be a New Year's resolution. Just go out and check how they're doing. I hear a cat. Let me go get her. Okay, I'm back. Yeah, I don't know exactly how much progress I'm going to make with this engine and the game this year. I am thinking about applying for a master's program for computer science, so I do need to study a decent amount. Good thing is a lot of the math and everything kind of overlaps what I was going to do anyways. with the rendering and everything and the engine and stuff. So, but yeah, I gotta start getting better with my data structures and algorithms, that leak code grind and whatnot. Gotta get that going. Gotta go over, I don't know, the college that I went to before didn't really, I think like it was a computer science degree, but it really felt like I was doing mostly like software engineering things, which is good, but also it doesn't aptly prepare you for doing the GRE and like applying for like a master's program. So I got to go back and properly go through it this time. So yeah, see how that goes. Yeah, everyone was going crazy over computer science a few years ago, and now it's a bit quieter for people working on it. A lot of people that did the degree, and now they're like, okay, well now what? But I don't know, for me, I feel like at this point, like I was feeling very aimless when I was doing my previous degrees. I was kind of just going through the motions, and I was like, I'm going to do the medical field and I'm gonna do it for the money. I mean, no one wants to say that out loud, but you know, I mean, I think at the end of the day, people go there for the job security and the money, and then what is it? I don't think you should be ashamed of saying that. Sometimes it is what it is, you know. But I think it was generally that also that kind of like turned me off from it. I was like, damn, especially the way the whole medical system is set up in the US and how they treat the patients and everything. And also just, I just wasn't passionate about it. But software engineering, I love this. Like, I genuinely love this. Like, I could do this for like however long. I don't know, call it, what is it? What is it? What was that? I was gonna say confirmation bias. What is that other fallacy? It's not cost fallacy, but you know, I think I genuinely love doing this. Anyways, enough yapping from me. Let's get into the code. So everything looks like it's compiling. That's good. Haven't really done anything that would change the editor yet. So let's go ahead and get back into the system. Okay, I think in its most, let's start with the most basic case, and I'll start adding all the extra features in and whatnot. So let's head over to the particle system. Particle service. Is it not indexed? Oh, you know what? Yeah, I think I know why it's not indexed. Yeah, what did I do? Sure. Alright, let me open up this folder really quick. I'm gonna close out this solution. I gotta rebuild my environment. I might rename this too. Actually, yeah, I am. Windows Gen projects. VS project files. It's a long name, but yeah. I guess we'll adjust the readme too. Windows Gen VS project files, Visual Studio project files, right? The other one's VS Linux Gen make files. Yeah, and then let me go to the readme really quick and fix that. I think somewhere in here Was it VS underscore? VS underscore. Let's find it. Wait, reference it okay, just once. Okay, so now it's called Windows. I might have to update my GIFs as well, but whatever. It's fine. I'll leave it for now. Windows VS Gen project files. Maybe it's Gen VS project files. Maybe that's what it was. VS project files. Yep. Okay, so GIFs aren't going to be exactly lined up. Maybe I should fix it. I don't know. Build Gen VS project files. Okay, well, yeah, should be fine. Windows Gen VS project files. Well, I'll update this from when I do Linux as well, so yeah, it's fine. All right, let's open up the solution again. We're gonna change the README, yeah. All right, let's see if that pops up now. Properties. Wait, did I even call it? No, I did call it. Particle service. Yeah, there it is. All right. So I think the first step is to just render a particle. Right? I think that's probably a good idea. Just get that to work, yeah. So what we probably need to do is maybe go find a render spec that's somewhat similar to this. Probably a good idea. I might have to make an interface with a camera. Oh, you know what? Yeah, actually, I think I do need a separate OnUpdate versus OnRender function. Yeah, I'm gonna go ahead and do that right now. I'm gonna pass in the camera. So we'll go ahead and do this here. Hash include Gargano rendering camera.h. Let's go here. Let's go to camera.h. I forgot how I set that up. Okay, yeah, so here we can pass in a camera and then use its projection. Okay, you know what? Maybe not. Let's do like the view projection image. Okay, let's not include this actually. But what I will do is maybe include math. Oh, there's math right. We're gonna do a static void on render. Do I call it OnRender? Do I even have OnRenders for all my systems? I think I call it push rendering data. Maybe I should change that to just OnRender, honestly. Because on my, what I'm referring to is if I go to like my runtime UI, right, and I go to like push, this is what I call like when I push like data, push render data. I guess I should keep it consistent for now, but maybe I'll switch it to OnRender. Yeah, you know what? Yeah, let me find all the push render datas. Actually, let's do Control Shift F. Push render data. So I remember I used that term because I thought it was descriptive, and it is, but I think OnRender might be better. now that I have a little bit of hindsight. Yeah, let's go with all of them. Okay. Okay, and we're gonna do OnRender. Multiple matches, yep. It's gonna take a minute because I do use it in a lot of different contexts. Push render data, yep. And you know what? All the unconfirmed references too. Because I think I'm the only place where I actually use this type of name. Yeah, let's try that. Just do it for everything. Do Control Shift F for push render data. And let that search for a bit. Give me a sec. Ooh. Oh shoot. Ooh. It's hurting. Perspective and projection. Okay, so I'm kind of just thinking to myself right now how I want to do like the projection matrices and everything. Is this finished? So like one thing I definitely want is, and I think one like kind of key staple of particle systems is that you usually do like quads, and then you usually billboard the quads. So if you're doing it in like a perspective projection, right, then you would place the particle at its correct location, right, in 3D space or whatever, and then you make sure you orient it so it's a billboard, so it's facing you, right, so that no matter what orientation you're looking at it in, it's always flat in your perspective. If that makes sense. I'm just wondering how I want to do that. There's a few ways I could go about it. I could manually like move the vertices of each particle to align with the camera. I could just make it a straight, also like kind of orthographic, so like it's like I don't even mess with the rotations, I just flatly like have it facing you, and then the only rotation that you would apply, of course, is like if it's rotated around the axis that you're facing. So like it's kind of like if you're looking at like a wheel in a car and it's like spinning type of deal, right? And like the only rotation, like the car for the most part is fixed in the axes, right? Like going like front to back, right? Like you can turn the car, like, right? And then like maybe like if it turns the front wheel, it turns that. But if you're just going straight on the highway, the wheel is just spinning around its axis. That's the main turning. That's the one we're worrying about for the particles, since it's being billboarded to you. Okay, I guess we're not processing anything. I'll deal with that in a moment when I start rendering stuff and getting into the details. Okay, so it looks like I switched everything to OnRender, which honestly makes a lot more sense. Okay, so we'll push back OnRender. Yeah, I don't think I need a time step, but in this case, I will need a map board. We'll do a const reference for this. And I'll say view projection. So this is assumed that it's the view projection matrix, right? And maybe I'll make some variants if you want to like either use the view projection matrix or just use view and then, or just use the projection. Maybe the view will get skewed. I don't know. We'll see. But yeah, when you want to render, you need to provide the camera's projection matrix, and then you're good. then maybe there can also be an OnRender that just doesn't take this in, and then it just gets drawn directly to your brain facing view. Could be a pretty simple one, to be honest. Okay. I think that's basically it. So let's go back to Init, and we'll go ahead and grab a render input spec that I use. And again, the render input spec is kind of like a, I mean, it's kind of a loose analogy, but it basically does the same thing. It's kind of like a, in Vulkan, they have their like render pipelines. It's kind of like that. This describes everything. I'm not super happy with how this comes together. I will take another look at this later. But yeah. Okay, so let me think. What is the rendering input that is most similar to this one? I think it's the Runtime UI. Because yeah, we're rendering a bunch of quads. That's the same thing basically. So let's go to Init, and we'll just join this and then go from there. So looks like this does a lot of this stuff. That's cool. You know, we'll just take all of this. And then we'll just fit it for our use case. Let's put this down here. And then do hash if 0. Alright, so it doesn't keep yelling at me. There we go. Alright, so Init, right? Okay, so we have the AddParticles context, right? This is a vector of particles. I may switch it over to being an array at some point. I don't know. Tiny bit. It's a bit faster to access. But I'll keep it as a vector right now because I don't know what the min and max sizes are going to be. And also, this is like a particle, what is it? Maybe I can make that like programmatic, I guess. So that like, if you have a different game and you want to like boost up like your particle size, maybe you can resize it with like a different starting value, depending on like the requirements from your game, right? I might be thinking a little bit too ahead though. All right, anyways. AddParticles context. Is equals to create graph. And you know what? Since we're here, well, that's okay. No, I don't think scope applies here. Actually, I think it is a graph. Yeah. Particle context. Also, at some point, I am going to take another look at how I do this memory management stuff. Do I have to provide anything? I think it's fine. Initialize context. This is the first time I use this, so let's go back here. All right. So that's particle context. Yep. So then we're going to say AddParticle context and particle pool dot reserve. Do reserve, and we'll do like 1,000, I guess, like Cherno. Sure. That works right now. Maybe do maybe rethink maybe rethink this rethink this, yeah, I don't know. AddParticle context and put render spec, do clear data for now. I mean, yeah. Just to be safe, I suppose. particle context. This is stack allocated, so I'm fine. Okay, here's a bunch of fonts and whatnot. This is default fonts, UI. Okay, so I think this is good. Basic particle context. And I'll say here, initialize rendering data for particle. Okay, and then this way we can start. Yeah, I'll put it in its own little scope. I think I do this so I don't get clashes with namespaces when I define multiple of these in a row. Alright, and I think I'll just go ahead and copy this over. And then we'll just start defining this from here. Where this was from. Oh, because I didn't complete this. Alright. So, oh yeah, it is a flat color shader, huh? Okay, for now I'm gonna keep it as a flat color shader. Yeah. Again, this rendering stuff needs to get dealt with later anyways. Color texture, text, oh, yeah, yeah, I'll keep it as none for the texture input. And then yeah, the series of bools is weird. So we have a circle shape, that's definitely a false, yeah. Projection matrix, yeah, true, yeah, definitely that. Entity ID, true. In my case, do I need to be selecting particles? Probably not. Yeah, probably not. I'll keep this as false. Would you need to select a particle? Yeah, I don't think so. It's just wasting memory. I can see a use case later, but I'm not trying to get every use case working immediately. Draw index, I guess I'll keep the thin rendering style. What ones do I have again? Draw index, draw a triangle, draw a line, draw a point. Okay, so I know draw a line and draw a point are pretty simple. Draw a triangle versus draw index. Okay, so this means I need to define both the indices and the vertices for this context, which is fine. Yeah, that's fine. Auto, yeah, I don't love doing this auto thing, but get shader. Okay, so I need to include shader here. Oh, wait, it's right there. Oh, we need assets. Yeah. Hash include or no assets, asset service. Okay, there we go. Tip component, I believe, is defined in shader, so I think we're fine there. Kind of weird now that I think about it, but yeah. Alright, a color, we define it as white by default. I guess I don't have a problem with that. Maybe I'll comment that. Default particle color is pure white. Alright. Shape is a quad, yeah, I don't disagree with that. We get the S quad index vertices, I don't disagree with that. We get the indices, don't disagree with that. Thing is, this is okay, this I might have to over the index or the is naming scheme. Yeah, I don't know. I will have to overload this if I'm going to start adding billboarding, especially if I'm doing perspective projection, but for now I'm just going to do it flat on the screen, so it should be fine. Okay, now this is where I define these, so let's just do one really quick. S particle context. Particle render spec and shader. Yep. Okay, there we go. All right, so that means the render spec should be initialized. I can get rid of this garbage. What the hell? What's going on here? Okay. Is this good? It's good. Okay. So I can get rid of this now. I don't need to worry about this. Oh, maybe, sure. I don't know. I mean, it's true, I guess. I guess I can do if S particle context. Okay, well, at least I can see if I, in the log, I should be able to see if I call this. That's good. All right, and then this one. All right. So yeah, we want few of these things. Make sure I clear the right data. So sParticle context dot m particle render spec dot clear data. Yep. Yeah. What else is in here? We have a particle pool and the render spec. The particle pool will fall off naturally. Its destructor. So let's see. S particle context. I guess maybe saying dot set is more descriptive. And then that's S particle context. Let's say particle system. Yep. All right. So that should be the init and everything. All right. So technically, we should be able to render now. We need to make sure that we call this in the correct locations, yeah. Let me do that really quick. Let's go to the editor. Yeah, for now, all of my function calls for handling on update and on rendering and whatnot. Those function calls, wait, what was I talking about? Oh yeah. Okay, so like managing like on updates for different systems and whatnot, that is handled explicitly by all of my executables. So in the editor and the runtime, they all call like the AI service, the runtime UI on updates, the and in this case, it's gonna be the particle system as well. So they're all always being called. Later, when I get into handling my systems more explicitly, I'll change that up, but for now, it's fine. So, yeah, let me make sure that I am calling init and terminate properly. This is the wrong place. Why am I here? Editor app. Okay, let's include the particle system. Argano particles. Particle. Wait, what? Yeah. Okay, and then let's make sure I call these things. Probably should do it around here. Yeah, with this one, that makes sense. We'll do particles, particle service, init. Okay, and if we do an init, we gotta terminate as well. What is wrong? Oh, right, yeah. I always forget to do this. Yeah, that should fall off. And then let's see, I'm just gonna put it wherever I do this here. Yeah, there we go. Terminate. Okay. And then the runtime is probably gonna need a particle system as well. So let's head over to the runtime. Find that. The server doesn't need a particle system, it's a server. Okay, where did we call this? Okay, here. Yep, and this doesn't know what it is because I need to include it. I guess I'll put it in the H. Why not? P particles. Particles. There we go. And then particles. Particle service. Yeah, and yeah, again, this file is horrible for compile times. If you're including in like a lot of different things, but if you just need like a really quick include file for everything in the engine, this, especially if you're just making like a very simple executable, this is very easy. Just slap it in there and call it a day. All right, so let's go to wherever I do this and do terminate. There we go. I gotta make sure I call the right functions. What was that? Okay, so we're calling terminate, and okay, so also maybe let's call OnUpdate and maybe OnRender as well. Let's find a good place for it. That might be easier to find here in the runtime app, actually. So let's go look at the structure for this app. Again, this is the executable for the runtime, right? So it has all the lifecycle event functions, which maybe should be in its own little section, right? Now that I say that out loud, it's like, yep, maybe I should do on event. Okay. Ooh, okay, let's see. Open project, yep. Alright, so OnUpdate. OnUpdate, you might want to call OnUpdate. I'm gonna find wherever I deal with the AI service. Yeah, let's do AI service. AI service. Update runtime. Yeah. Particles, particle service, OnUpdate. And we'll provide yes. There we go. And then OnRender. I don't know if. Okay, so it looks like I render the code here. I have my UI somewhere, but I don't know where I call it. Runtime UI. And UI service. Service. On updates or OnRender, I guess. Okay, so I guess I do that here. Render UI. So I probably want to do the particles before the UI, so it doesn't go on top. That'd be weird. What else do I do here? Runtime, particle system, update, update on update. Render the entities, yeah. Okay, so yeah, probably want to do the. What is this? This gets the camera for the scene. Okay, this is just the general OnUpdate, and then this. Wait, what does this do? Get primary scene camera. Oh, this is all part of the bring the UI. Okay, because I have to get the camera from the, how do I say? Don't tell me I'm doing like some complicated function to get this every time. I am. That's silly. Yeah, I need a. Yeah, let me put a to do here. To do. This is ridiculous. Not the worst thing ever, but because I mean we are getting a view for all of the camera components, which is a subset of the entire scene, but it's still ridiculous for looping through each one every frame. Yeah. Okay, so before the runtime UI, let's go ahead and draw particles. Particles, particle service, OnRender. Okay. Yeah, you know what? I'm gonna move this down to here. And actually, I'm gonna take this and put it here. And let's say get primary main camera to render UI and particles over. Okay. Wait, give me a second, I'm gonna cough. Okay. And then here we just provide the camera transform. Wait. Wait, do we even use this? Hold on. That's interesting. We don't even use it. You know what? Let me go over the editor UI really quick because wait. Oh, where? I think it's UI editor viewport, the one I was just working on. I think I do something like this. It's probably it's not an update. This is where I render it, right? Yeah, here we go. On render, and then we provide the view projection matrix. Okay. Okay, and then I'm gonna take this. I'm gonna get rid of this. And I'm gonna say put this here, right? I'm gonna take this, actually make it more internal right here. And I'll say only handle UI and particles if a main camera exists, right? So even though I don't use the main camera here, it's still not a bad idea to not render it because I guess that's situation dependent, but generally speaking, you probably want to have like a camera available if you're going to render things on top of it. If not, you probably just don't want to render anything. I'm just gonna go with that now and change it later if I have to. But definitely for the particles. So there's no main camera, I'm not bothering with the particles. On render, okay, and it takes in a, so this takes, it's gonna take in a view projection matrix, which I believe I have an example of this here. This is the editor camera. We don't have an editor camera, but we do have a scene camera. And I believe with the scene camera transform. I don't know if I care about the transform. Yeah, I don't think I care. But I think the main camera, I think maybe there's a function gets projection. Is that right? Hold on, no. Wait. I do something like this in the runtime, I believe. A render scene with the camera, and then its camera transform. And then this takes in the camera and the transform matrix. Do I form the view projection matrix anywhere in here? Wait, what's going on? Oh, here it is. Okay. I thought I was like getting messed up for a second. Okay, so we do this. Okay. Sure. Yeah, then this begins a scene. And scene. Okay, well this is how we form a view projection matrix, so we'll copy this really quick. Camera transform. Wait, give me a second. Let me get some water really quick. All right, I'm back. What is that? Okay, all right. Okay, so wait, what am I looking at? Think about a render scene with a. Oh yeah, and this produces the view projection matrix for a scene. Yeah, that's cool. So yeah, this I definitely want this. Did I paste this anywhere? This is what I wanted. This is the transform, and then this is how we get this. So we're gonna put this right here. We're gonna do camera transform. And it's main camera. Okay, and then we only process this. over here. Get rid of this. Get a camera transform. Oh, this is a pointer. Okay. Should I get the transform? Yeah, I'll do it here. It's fine. Okay, nice. So on render now we provide the transform that we need, and then we'll do something similar to the way I do on render for the runtime UI. Okay, so I am calling on render, I am calling on update. Okay, I think that's all of the lifetime things hooked up at the places. The only other thing is maybe the editor UI as well. Oh, and the editor is going to be different, I believe. Not too bad though, but yeah, it's going to be a bit different. So let's go over to the editor. And I think we need to treat, or we just need to handle the particles. Okay, wait, let me see. I think it's in the editor app. Or no, viewport panel, That's what you want to worry about. Because for some reason the viewport panel is handling a bunch of... It's handling this, which is weird. It should not be handling this. Maybe I should move that right now, actually. OnUpdate simulation. Yeah, this should not be handling this. The thing is, all of these need the camera. Oh, that's why I put these here, because they all need the camera. Yeah, I guess so. I don't know. Okay, well, wherever I put the AI service on update, I'm gonna put this here, I guess. So, project. Oh, no, project. Particles. I need to include it because editor is now more specific. Probably don't know. Particles. Particle service. There we go. Particle service. Okay, I'll update runtime. What's going on with that? On update simulation, on update editor. Yeah, I don't think you need to be bothering with particles in the editor. Okay. Then yeah, here we go. So if camera entity, right? Then we'll get the transform stuff like we always do. And then if main camera, then again, I kind of want to move this over here. It doesn't really matter, to be honest, but yeah, we'll put this here. And this one just draws to the viewport. It doesn't even care about the camera again. So render runtime UI directly to viewport bounds get camera transform, and then here we're going to do render particle and this one is going to be based on the camera transform, definitely. So we're going to do particles service, and then on render, and then I don't have that anymore. Okay, so it's going to be, I believe, the projection matrix, man camera get projection times the camera transform. There we go. So now we have the projection matrix. Nice. Yeah, and maybe I'll make a variant where if there is no main camera, I'll just kind of just draw the viewport. I don't know. I'll see. And then I'm trying to think. So basically with this means that the particles will only be drawn. How do I say? They will only be drawn when the runtime is working. Yeah. Or when you're like playing the game. So that means I might need to set up some stuff in the scripting for particles. I might also need maybe I'm gonna do something similar to Cherno's where he has this, so I'm probably gonna add support for querying the mouse's location inside the scripts. That should be pretty easy. Just returns 2 floats, or like a vec2 for like the mouse location, and you can use that to decide where you want to place the particles. Yeah. And then I'll probably add a bunch of overloads for like creating particles with different, how do I say, complexity or whatever. I was kind of thinking of like maybe an ECS type of system, or having different types of particle interactions and whatnot. Not like a full-blown ECS, but I was thinking maybe like hear me out. Like instead of storing all of the particles as like big structs, right? Maybe separate the structs out into like a series of vectors, right? And then like in ECS, you have like an index for each particle. And then when we're processing each of the particle, like quote unquote components, then they can be processed directly in their buffer, right? For the data that's relevant. And that way it can be a bit more performant, a bit more cache cohesive and whatnot. So what I mean by this, I'm not just spitting into like air or whatever, but let me go ahead and show you what I mean. So you can kind of see here, right? Like how you have all these different like things, for lack of better words, like different things in the particle, right? So we have like the position, the velocity, you might need that just generally, I guess, and rotation. But maybe you don't want to bother with like a color start and color end, or maybe you don't want to specify like having like a lerp or whatever. So maybe you can kind of like build this out into components, and then you can store like vectors of like just this parts of the data, if that makes sense, right? And then that way, like say for example, if you had like particles and you wanted them to follow like physics rules, I can just have a buffer of particle like data that follows physics rules, right? And that way I can just loop through all the ones that follow physics, and the rest of them I don't need to care about. Or, and then that way, the particles that interact with the physics can just interact with the physics, and the rest of them that don't do that can just mind their own business. Or if you want to get like super into like doing lerps and like complex equations, you can maybe like add like an equation component, and the equation will be processed, and then like you can use a lerp to figure out where in the lifetime you want that what is it, you know, you do lerps right with it and figure that stuff out. And then yeah, you can have each of those like functionality as their own like little component type of deal, and then you can kind of build up your own particle. And then when I'm doing the OnUpdate and I'm processing the information, I'll go based on the, instead of having like a single vector buffer, yeah, instead of having a single vector buffer like particle pool, I could have multiple like buffers, like vectors or arrays of like the components. And then when I'm processing the physics, I'll just, like, I'll have like an array of physics component, and then like put the size of like 1,000, right? And this is like physics comp, right? And then we'll just loop through this physics comp, and then this particle pool will just be a bunch of indices, right? And then you don't really ever bother like looping through all these. You just loop through these, right? The complexity comes when like you need how do I say, like for the particle, I mean, for the physics comp, of course you need the velocity and location of the particle, right? But also, generally speaking, you would just need that for the particle, like anyways, right? So I need to perform it in a way to like access both of that data, if that makes sense, at the same time. And in a way where we're still looping through both of the data's cache linearly. I'm not like jumping around the caches. Yeah, it's getting into like ECS stuff. This could be fun place to kind of work on memory management like this though. Yeah, I might lean into doing something like that just so that way I can start really going crazy with the particles, adding equations, adding stuff, and not worrying about just getting this giant particle thing that is super huge or whatever. Because I want to add all these features and whatnot. I could just break it up into a series of vectors or arrays or whatever. Yeah, let me think. Okay, I'm getting ahead of myself though. I am getting ahead of myself. Okay, but yeah, I think I'm good on hooking up all these functions, and then I just need to call AddParticle at the correct time. Okay, I'm just trying to think of how I can test particles. Okay, I'll think of something right now. All right. Well, anyways, everything here is being called, it looks like. So yeah, the next thing is just to get things rendering. So let's go find the render code for the Runtime UI service. Let's head over down to OnRender for this, I guess. I think this one calls this with the ortho projection, sure. Okay, begin scene. This one clears the depth buffer. I don't think I'm going to clear the depth buffer. Then we begin scene, sure. This one provides this projection directly. Yeah, when you provide a camera, this does the view projection. Okay, so I just have these different variants of this. It's cool. But yeah, this is the one I'm going to use. Just provide the projection itself. Maybe I'll rename this. I'll do beauty projection. Okay. Transform view matrix. Camera. Interesting, I added this perspective camera. Yeah, I guess so, huh? Maybe I could add something similar to this. Okay. Yeah, I don't know. Alright, anyways. So we get the appropriate matrix, right, that we're viewing from, and then we just loop through. And then how do we submit it? We just submit the input spec. For all of these, I believe the transform matrix is pretty simple. We are going one window at a time, which for the particle system is probably not a good idea. I might want to do like a I don't know, way to submit multiple at the same time. Then we create the background rendering data. Push the window ID. Okay. Yeah, I don't care about this. Yeah. Do not care about that. And then we call the rendering code for each widget. So I don't even care about this, to be honest. This is probably where I need to come from. So we get its scale on the based on the viewport. We get its translation based on the world. Yeah, okay, sure. Location, and then create background rendering data. The transform, we set it to the particular color for this thing. That's probably what I have to do individually for this. And yeah. All right, I think I'm just gonna copy this. Yeah, I think I'm gonna copy this. Let's do this, and then. Well, actually, okay, let me just copy this whole thing, and then I'm gonna just get rid of the things that are not relevant. So let's head back. All right. So I'm not gonna bother with OnUpdate right now. I'm just gonna say that every particle that I add is just gonna stick there for now. We need the rendering API. Rendering service, what we want. Okay, less errors, that's good. Here we're just gonna provide the view projection. There we go. There we know this overload leads to here, which just provides projection. It's fine. I'm not going to clear the depth buffer because I want the particles to actually live within the scene. Well, actually, hold on. Wait. Please remove this. I'm actually gonna leave this on for a second because I want to see them on top of everything. But once I can see them on top of everything, I'm gonna remove them. I'm gonna remove this. Because again, I want the particles to live within the scene, so it needs to, you know, be drawn inside the scene, right? But for now, just for testing purposes, I want to be able to see them on top of everything. And then this, yeah, I don't need to worry about this as much. I mean, I guess I could put an assert here, Search s underscore, what are you talking about? What's all this? Particle context. Do I want to do that every OnRender? Yeah, it's a quick check, and plus it gets pulled out of the runtime, so it's fine. Terminate. Yeah, I actually do want to assert that. And also, maybe also assert that this does not exist here. That'd be a good idea. Okay. This looks good so far. And seeing, yep. Submitting to the GPU. That's good. Alright, so here's where things start to differ. We're gonna do a for loop. And you know what? Let me just do an f0 here. We're gonna keep this all the way into here, hash end if. Okay, now we're gonna do a for loop for the AddParticle context. Okay. What is this again? This is a cardinal particle. Particles. Particle reference. Particle. Alright. Do I want to modify it? Probably, actually, yeah. Render all particles. I guess for each particle, we're just going to render it. So we're definitely going to need a submit. To the GPU. S particle context. There we go. So we'll push that. What else? Okay, so we don't need this part. Maybe the color data. Probably want to do this, yeah. Well, I'll keep it white for now. Just keep it simple. Okay, but this we need to set. This we need to set, and then we'll get that. This is the bottom left translation, which is just a vec3. So for now, we'll maybe make this a constant, just to test it. So let's do this. Okay. Looks like we don't have, oh, it just doesn't know what this is, right? Scale, I think by default it should be fine. Or maybe not. What is scale in this case? It's a vec3. Okay, I'm not going to worry about this for now. Yeah, I'm not going to worry about that for now. We just want to translate it, and then we're going to translate it. Okay, wait, I gotta think. So if we have a view projection matrix, and say we're using the scene camera. Okay. And then we're clearing the depth buffer. We should render on top. I think I'm thinking a little too hard about it. I'll just keep it as the identity matrix for now. Well, let me see how I'm calculating this bottom left thing really quick. So we get the window, calculate size. This gives us in viewport scale the location. Image translation is calculate roll position based on this, and then calculate translation. Okay. Initial translation plus scale.x divided by 2. Oh, okay, so that's just orienting it correctly for us in there. Okay. I think I'm just gonna say glm map 4. It's just the identity matrix. Let's do that. And then we'll see, so that should just give it like all default values. And then of course we'll move it based on the view projection, but that should put it at the world's origin. It should draw on top of everything else. Yeah, okay. And I think what I'm gonna do just to test is in the init, I'm gonna do remove this for testing. I'm just gonna say s particle context, or maybe I'll just do add particle, and then we're gonna create a particle. It should have a default constructor, I believe. So we'll do, yeah, just make a particle. Maybe I can just do this actually. Pass it in. There we go. Alright, so we'll add a particle, and then hopefully that means when the runtime starts, we'll just see it. And that'll be cool. Yeah, I'm trying to think of anything else before I run this that might be an issue. Yeah, this is render. I'm gonna get rid of this. On update, this is gonna be kind of complicated, so I'll get to that in a second. But just rendering should just, I mean, just render it, right? Really shouldn't be doing too much else processing. Okay, let's run this. Let's see what happens. I'll let that compile for a bit. I'll be right back. Actually, yeah, give me like 10 minutes or so, maybe even 20. I might just put 20 just to be safe. I'm gonna get some food. I didn't grab any food earlier, so yeah, I'll be back. Okay, actually, I'm back. My bad. I'm gonna get some food in a moment. I'm just gotta wait for a bit. Okay. So, let's see. Okay, I don't see anything. You only see if everything initialized and everything. Okay, it says particle system init, so that's good. And then if I close it, hopefully it doesn't crash. Okay, here we go. Particle system terminate. So there we go. All right. So it's initializing and terminating, so that's a good sign. I just don't see anything, which is kind of a bad sign. Let me check that rendering code again. Or actually, maybe it is there, it's just really small. I don't know, maybe I should make it a different color. Also, this is actually so really broken to mind that. Okay, I don't see it anywhere. Let's do a few things really quick. So first thing, probably I'm gonna put this into its own scope because I want to get rid of this later. Okay, so we'll add a particle. Oh wait, AddParticle doesn't add anything. Right, okay, so that could be the issue. Huh. Okay, well, I'm gonna do two things. I'm gonna add the particle. So we're gonna do s particle context and particle pool dot pushback, or maybe replace. I don't know. Whatever. Let's put back particle. that add the particle. Yeah, so we add the particle. The other thing is I kind of want to set this. Testing color is red, so we'll make all this 0. Just so it's maybe a little easier to see. I don't know. Oh yeah, and then I have to provide the buffer and shader, so. There we go. So we'll set it to red, so it's a little easier to see. Yeah, let's just go with that for now. Let's see if that works. Let's see if we can see our first particle. That'd be nice. Okay, I don't see it anywhere. That's kind of disappointing to mind the UI. Still in the middle of doing that. We are providing the projection matrix. We're running it over the... I'm just trying to think of what the issue is. Okay. I think what I'm gonna do is... Wait, scene... Transform, huh? Let's go check out this OnRender. Let's make sure everything's running. That might be a good idea. Okay, we are running. We are clearing the depth buffer, which is what I want currently. We start the scene with the projection, which is a bunch of numbers. It's kind of incoherent, isn't it? But it looks fine to me. Yeah, it looks normal to me. Where is this being ran? Let me take a look at that. Okay. So this is based on the camera transform. Oh wait, we're not looking at the origin. We're looking at like the corner of the origin. Maybe that's why this is broken. Okay. One way I can test that. And again, I have so much temporary code. I gotta be careful doing this. Close this. Let's see. If play, then we render the UI and also the particle system. Otherwise, maybe let's push the editor camera's projection matrix. Yeah. So instead of play, which I think we have, yeah, either edit, play, or simulate. So if it's not play, as in it's either edit or simulate, then let's go ahead and we'll do basically this. But this time we're going to use the camera. So we're going to use the main editor camera. So you do edit editor camera. That begets view projection. There we go. And so now this will render from the editor camera's perspective. Okay, so maybe I can like look around and see. Also, I'll make sure this is being called too, but to get rid of this garbage. Yeah, because I don't really want the particles rendering in the editor like that. Really, it's just like a runtime thing, but yeah, I gotta see. Gotta see. All right. Oh, hey, there it is. Okay, cool. Yeah, that's what I thought. Okay, cool. So we have our particle and its persistence. Nice. Nice. Yeah, we cleared the depth buffer too, so it is visible and it's from this. Yeah, okay, cool. Wait, so why couldn't I see it earlier? What? Yeah, wait, why can't I see it? Weird. Hold on. Yeah, we are calling it, and we are rendering it. So what's the issue? Yeah, it's rendering it. So what's up with this? I should see it right here. For some reason I can see it from the editor camera's perspective. So it is working. And it's drawing over the things. Yeah, because it's clearing the depth buffer, so it's always being drawn. Yeah, I should see it over here then. It's weird. We are using a projection, like a graphic projection for the scene camera. Wait. What is the scene camera? Let me see. Yeah. The this is inside of the camera's projection, definitely. Okay, so what's wrong? I don't get it. Weird. Let's see. Am I multiplying it wrong, or am I like? Wait, hold on. Maybe I'm using it wrong. So we get main camera dot get projection, and then camera transform. Which, if we do get transform, translates it and scales it by the correct amount. Yeah, I don't really see an issue with that. Weird. Weird. It's been called. Definitely. We are clearing the buffer, so that wouldn't be the issue. The projection multiplication is being done in the, how do I say? The projection multiplication is being done on the graphics card, the final one. So I can't really view that happening, but I mean, it is working because this is working. What a conundrum. Is this taking in a constant reference that way? Maybe you can't take in like an R value. But the values seemed fine earlier. I don't know, maybe I could try it. Okay, yeah, I mean, doesn't hurt to try. Not for view projection. Camera view projection is equal to this. Okay. Yeah, but usually if it's like an R value, L value issue, it'll be a compile time issue then. Not a runtime issue. Or maybe I'm just wrong, I don't know. Alright, let's see. Constant reference, huh? What's going on, man? Maybe there's a clue with the way I do this lines. No. Well, I am viewing that one from that perspective. Maybe. I don't know. Let's go take a look. Maybe something needs to be inverted first before I pass it. When I get the transform. Oh, wait a second. I'm just getting the raw transform, aren't I? Oh, I am. Wait. I think I know what's wrong. Yeah, that might be the issue. Try that again. Yeah, I never inverted it anywhere. And that's not a problem here, because whenever we update the projection, or update the view, we already invert it. But I believe when we're grabbing the transforms from this camera and we're grabbing this, we do not invert it. So that's why. So it is in the screen, but it's like inverted the wrong direction. So like if I move my camera around, I probably could have saw it. It just was in the wrong place. So I'm hoping that was, I don't remember if I just compiled it or not. Let's take a look. I'm pretty sure that's the issue. Yep, that was the issue. Yep. Okay. And the AI sucks. I still can't beat the final level. I've been trying sometimes. I don't know. It hurts seeing the UI all messed up. Okay. Alright. Well, anyways, that works now. That's good. So I can get rid of the particle now here and get rid of this. Let me do let me check this. Oh, there's a lot of the dependencies, aren't there? Yeah, VoxG, GLFW, everyone has to do this, I guess. I gotta get rid of the dependencies. I just said eh. Is it a server dependency? I don't know. Yeah. It does work wonky, I agree with that. content browser, switch. Yeah, I guess so. What was I looking for? Oh, okay, I remember now. Yeah. I'm drawing that particle right now. Okay, so now I know I can draw particles. Oh, that was step one. So now, let's go ahead and get rid of this. This was super temporary. All right. Trying to think of what the next step is at this point. So now I can position the particles wherever I want, which is nice. Okay, I think the next thing maybe is adding a particle, like being able to add it programmatically, maybe. And then maybe I could put it in the game. I don't know. Might be kind of nice. But you know what? I think I want to get Cherno's implementation done first. Yeah. I wonder how I can get the location based on screen space. I think I already do that with the mouse input thing I have. So there's a few steps in this, honestly. So I could get the viewport location, and then I could get the... Okay, let me write out like a list of things to do, because I think I'm kind of all over the place. Now, getting it to render period is like a big first step. So the next thing is maybe add particle from scripts. Right, not a bad idea. And that way I can just add like a basic particle. And I think maybe the most basic way you could specify the particle is just provided a position and a, how do I say, a position and a lifetime. Maybe a position, a size, and a lifetime. Yeah, you know what? Yeah. And I think what I'm gonna do is for the size, yeah, I'm not gonna bother with this. Math position. I'll do math back to M. There we go. And I'm gonna get rid of this for now. That's cool, but it's a little too complicated for me now. And also this is a little too complicated for me right now. And then rotation. The velocity, I don't think I'm gonna worry about right now. And yeah, start runtime. I think for this, I'm gonna keep this private actually. And make this public. I mean, it's default public, but might as well be explicit about it. I know this isn't really a struct at this point with this thing, but I don't know. I just want this to only be accessible here, like inside of the service. And then all you have to do is maybe just provide the particle and then provide the lifetime. yeah, it's not bad. So maybe with particle, I can add a float lifetime. And then here, I'm just going to provide a float lifetime as a separate thing, and then that will be calculated. And of course, the start and end time will be used to calculate the lerps and everything. And then for the end time, start time, should I? I believe I have, okay, let me check how I do the whole delta time thing in the engine again. Okay, so we get the time points, we do all this stuff, and then we get the timestamp, right? And I believe by default, it's all in, okay, so this is in nanoseconds. Oh, this is in nanoseconds, okay. I don't think we need to be as this precise with the, how do I say? With the... particles, right? You'd be a little imprecise. It's not that big of a deal. This one I want to be like as high resolution as possible, because of course this is the time function, the main time function for the engine, right? So it needs to be as precise as it can be. Okay, what do I actually pass? This is the constant frame time, right? And this is like a float, I believe. Oh yeah, it's time step 1/60. Yeah. And the k constant frame time in nanoseconds is... oh yeah, this is just the conversion over, sure. A little bit of dimensional analysis and whatnot. I guess it's like a chemistry term, right? Okay, let me check really quick if I'm gonna get some food. I'll be right back. So yeah, I'm gonna be right back. I'm gonna get some food. This time for real. So about 20 minutes. Okay, my apologies. I guess I was on break for a little bit, maybe like 25 minutes. I grabbed some food and I was talking to my family for a bit. I guess I got a new follower though. If you're still in here, I appreciate the follow. Let me see. Sorry, I couldn't catch it. Let me see. Oh, hey, DJ, for sure. How's it going, though? Oh, Booty Boy. Thanks, Booty Boy. Alright, let me see. Right. Yeah, but can I see the viewers? I don't know. Usually it shows the number of people. Oh yeah, no, yeah. Oh, Saddam Dev's here too. What's up, Saddam Dev? I'm probably saying that wrong. Yeah, what's up, DJ Vibes? What's going on? I'm still eating right now too, so I guess I'll switch it back to the stream, but yeah, I'll be eating for a bit. Got some gumbo. Whew, damn. Also, if anyone's wondering, I'm working on a particle system right now. I just got the first particle rendering. I think my next thing is I'm going to try and spawn particles from my scripting system. And yeah, I think that'll be the base thing. Just make sure the lifetime stuff works and go from there. Got to a really argument about programming languages. Do you call... I think I do both. I mean, C++. I usually go with C++, the first one. But, CPP. The only time I say CPP is if, like, I'm, like, writing it as, like, an API or something. Like, oh, like, generate, CPP, right? C++, right? If I have, like, some function that deals with the language. But if I'm just talking about it, it's just the first one. Why, you guys having an argument about that? Why did I get called out for immediately not knowing what everyone else... Oh, they were like, it's semantics, I don't worry about it. It's a very weird hill to die on, to be honest. Yeah, that's how it goes. That be the internet, TBH. One good damn I don't mind. I mean, you know, everyone's got their opinion about everything. It wouldn't be a bunch of people. It wouldn't be a bunch of coders if there wasn't a bunch of people arguing over things that don't really matter. Like, it's C++, like, it's fine. Yeah, I mean, did they? They made the standard, right? That wait, Microsoft. Oh wait, no, I'm thinking of something else. Who's that one? The company that has that like C++ standard. I think it's Google actually, and that's the one that they enforce for their code base and everyone uses. Yeah, yeah. Yeah, having like a plus sign inside of your file name is kind of interesting. Oh yeah, and there'll be people will be arguing over it's .h, not .hpp. No, it's .hpp, not h. Like, bro, it doesn't matter. It's a header file. It's all good. Yeah, I don't know. All right, well, let me get back into what I was doing. I'll eat slowly. So yeah, I've been working on UI stuff for a while. I got really exhausted last time when I was working on UI. I think I coded for like 7 hours. I just posted it on my YouTube, and I got like 100 lines of code done because I was like staring at it, and I was like, I have no idea what's going on. Person that got annoyed with play Sea of Thieves. I think we were talking about Sea of Thieves. I don't know, did I get annoyed by it? I don't remember. Ooh, all right. Okay, so I'm trying to render particles right now, right? So if I believe it only renders in the runtime. So if I open up the runtime, oh yeah, I got rid of that code. Let's put it back for a second. I was looking at this time code for a second. Alright, let's go back. Init. Wait, what? Okay, no. I guess I'll put it back again. This also needs a lifetime now. I don't think I need this anymore. This is all kind of garbage now. I'm just using it as reference earlier. Okay, I think it was here. So I can do AddParticle, right? And then I'm gonna do a default for the particle and lifetime. I'm gonna do 1 second, but I'm not actually enforcing that right now. And then also I want to set the color. Well, it can be white. It's fine. All right, so this should render like a white particle in the corner. Let's go ahead and take a look at that. Ooh. It says we were, and you told me your friends keep telling you things about it. They don't have the best physics. I don't know. Let me real quick. The gumbo was bomb, man. Oh yeah, I switch over my Discord. Let me see. Secretly Harry Potter. Oh my. So have you been doing like a run of Sea of Thieves? I don't know. I don't really know much about the game, I'll be honest. I never played it, so I don't know. Oof. 200 hours in... That sounds like my hours for, what is it? 200 hours. I forget which game that have like similar hours for that. It's like, what is it? Like, I think, no, I think Kenshi have like 500 or 1,000 hours. Which one do I have 200 hours? I don't know. Honestly, I haven't been playing a lot of games in a while. I don't know if that's good or bad for game dev. Probably bad. I mean, yeah, get your money worth. I feel that. Alright, let's see if I can render this particle. There we go. Alright, so the particle's rendering might be probably really hard to see. Let me open up the full screen. There it is. There's a particle. Little quad. Oh, hey! Happy New Year's too. Yeah. Any New Year's resolutions? So, particles rendering. Cool. So, the next step at this point, get particle to render. That one is good. Maybe zoom this in a bit. Alright, so we got a particle to render. So, yeah, we probably want to add particles to scripts. I don't think of where I want to do that though. Okay, I think I have an idea. I think what I'm gonna do is I'm just gonna spawn particles around the scene. Right? Like randomly. And then I can test out the lifetimes and see if I can get that to work. So add particle from scripts and add lifetimes. That's a good starting point. Let's close this and then we'll take a look at oh, my scripting section. Yeah, so script service. Let's see. And get a PC. Oh, well. I feel it. I mean, for me, the don't get better thing, I'm just eating away. I don't know. But yeah, if you're doing your dev stuff, I agree with the PC thing, though. That'll be a good one. What do you mean it's out of the question? What you don't want to? I don't know. I had a friend for a long time that didn't want to, and then he just ended up with one. It worked out for him, so I don't know. Well, I don't hang out with a lot of people in cybersecurity, so yeah, I don't know. Couldn't tell you. I do know a few people who like do web dev, and they're married and whatnot. Yeah, all my friends that do coding, yeah, everyone's in a relationship. Yeah, but I don't know. We're like close to like 30 at this point, so I don't know. Ooh. You got beef? You got beef with the my god. I mean, if you feel so impassioned, I suppose. I don't know. I don't have a stake in the game. Ooh, okay. So, okay, these are the scripts that I exposed to my scripting system. Yeah, this is, or how do I say? I guess that's, here's a better way to phrase that. These are the scripts that I expose that I can like directly connect to like a function. So, you know what? The more I talk, and the more it still sounds confusing. I don't know. Let me head over to where I'm actually supposed to be at though. Here, okay. So these scripts, these are the scripts that are accessible in the actual scripts. So that allow you to actually like, do things, right? I'm thinking maybe I should write. I don't know which direction to go with this. I'm trying to think. Okay, I think first thing I'm gonna do, I'm gonna add particle service here. Right. Include Cardano particles particle service. Or not, I guess. I don't know. You okay, kitty? Oh my. Okay, particle service. Let me head over here, and then I'm going to add an API for, instead of doing this, void add particle. I still have a bunch of overloads of this. So the first one will be, I guess, just a math vec2. Vec2 wants reference. Particle location. Let's see. It's the exact same with architecture as a builder's dream. Wait, architecture's dream. Just nightmare. Oh yeah. It said WebGL. I don't know. Well, WebGL versus what's the new one now? WebGPU. That's the one that people use, or is like the successor or whatever. He said, I refuse to use it. What is his name? I think Shy Assassin. Was it Shy Assassin that comes in? Yeah, no, Shy Assassin came in earlier, and he works on WebGPU. I like his abstraction over it. But I do like to write my own renderers for things too. The shotgun's wild, man. Oof. Let's see. Alright. So add particle. Yeah, this is a very simple one. I guess I'll just have a bunch of function overloads for adding particles. So this one will go ahead and create a, I'm going to do it in place. Particle, new particle, and then new particle dot. Hopefully, the compiler can figure out what I'm trying to do. Maybe optimize this. Okay, well, the position is equal to particle location. Wow. Oh, it's supposed to be a vec3. Yeah, I guess I'll make it a vec3. Sure. The vec3 is, how big is a vec3? I think it's 3 floats, so 32 bits times 3, like 96 bits. Kind of big. Is it worth passing by reference though? Ooh. Let's see. All right. So let's just go with this one for now, and then everything else will just be the defaults. So particle position, the new particle dot rotation and size. We'll go ahead and yeah, okay, no, just do position for now, and then we're just gonna push back this particle. Oh yeah, and then we'll do new particle dots, and then here we probably want to be able to modify it. So let's go up here, and then we'll add a private, and then my brain work, please. Oh yeah, friends, and then particle service. Oh, wait, class particle. Okay, so now now we should be able to access the lifetime stuff. End time, start time. So start time is now is equal to let me go to the engine run. Is it gonna run? Yeah. Dun, dun, dun. Maybe I should have pushed my code already. Let me check what I've done already. There's a lot of yeah. You know what? Might be a good place to push the code. I changed. Yeah. Okay. Let's go ahead and do that. Modify name of VS Gen projects.bats script to Windows Gen VS project file. Let's stop that. And updates. What is it? Updates to README. The README. Empty. Reflect change. Alright. Two things with one stone. You wanna go out, kitty? Okay, my bad. No. I tapped out. What did I say? I just, particle system stuff. About it. That's about it. Viewport panel. What am I doing? Okay. Oh yeah. Okay. So add particle init. Terminate, OnUpdate, and OnRender. To engine, editor, and runtime. That should explain most of that code. Viewport panel. Yeah. Basically that change. Editor app. Particle service. Where did it go? It might be honest to ask, but how does someone wake up and say, yeah, I'll start going? Yeah, I don't think you do. Like you just kind of like, I mean, I don't know everyone else, but I just started like doing graphics programming, and then it just leads into engine development. That was me. Also, I don't know. I like writing my games from scratch. Like I was making another game. I think I showed you at some point. I don't know. But I made another game in Java. And I already had a bunch of systems in and everything. But all the abstractions were so like brittle, and it was really hard to like get everything and make everything in like a timely fashion. And at that point, you just be like, oh, we'll just use an existing game engine. But I don't know. I like doing this, so now I'm here. I hope that answered your question. I'm not sure. But yeah, I don't think anyone just wakes up and goes, I want to make a game engine. That's kind of like psycho energy, I'm not gonna lie. Okay, I'm gonna read this one. I don't even do coding for fun. I just want to get paid. Who finds it fun routing in sheer overtime for 8 hours, staring at the mountains of syntax errors my coworkers made? Yeah, I mean, the whole corporate thing does kind of hurt in general, right? I mean, honestly, if you want to get money, the medical field's usually pretty good. Usually no shortage of doctors and like nurses and whatnot. Nowadays, I don't even think CS is like a great choice if you want to make a lot of money. Yeah, today's all impacted and all the salaries are going down because no one wants to, you know. But when I started coding, I knew I liked it. And I've been, I don't know. For me, it's worth it, so. Well, I hope you find a job, man, that you get your money with. I don't know. Yeah, I don't know. When I was, what the hell? What is this? When I was growing up, I didn't really have like a passion for anything. I just kind of was like, yeah, I want the money. But now I'm at this point, I'm like, no, I actually do care about this type of thing. So I'm not pushing this. So I don't know. I guess it just be like that. Okay, you know what? Let me make sure this compiles before I try and push things. That's probably a good idea. Yeah. Yeah, let's do that. And also, please tell me my things aren't. Okay, good. Might be a better choice than that. Nuclear physics. I mean, are there jobs in it right now? I don't know. I used to do like a chemistry thing for my degree, but then I switched over to computer science. Even the ones with engineering, it's tough nowadays. I think it's just tough in general for like STEM. Again, unless you're doing medical. Right now I have like a nursing job, but I've been trying to get into CS. I'm thinking of doing a master's soon. I mean, I don't know. I kind of messed up because when I was in the CS degree, I didn't do as much internships as I should have. So my main reason for doing masters is to get into maybe like an internship. A lot of them are education based. But yeah. I mean, yeah, the market is ass right now. I will agree with that. I will agree with that. Oh my. Yeah, CS, IT, all that, it's rough. Albert Einstein. Oh my. imagine he's trying to get a job in this current market. What was I? Okay, yeah, I was just making sure it's compiled. I was like, what was I doing this for? Okay, so it does compile. That's good. Done. Let's continue the commit. What am I adding here? If you look at, there was an application procedures and plant ready, they finished ready. Yep, and then an AI is gonna run through the application. No one has the right keywords. You have a PhD and they're just gonna be like, but where's the project? You have the projects, but they go, but where's the PhD? Oh my. What am I supposed to be filling out anyways? Oh yeah. Gets a particle to render. Oh wait. Implements basic rendering function inside particle service page. Yeah. Functionality inside particle. Yeah, that's basically what I did here. Yeah, I've been abstracting this, but I don't know. Begin scene, that's like a nothing burger. OnRender, huh? Push. Yeah, I guess that's mentionable. Change push render data to OnRender. Throughout code base. Yeah, that's pretty accurate. Runtime UI OnRender. Yeah, I'm just finishing up this commit really quick. Dude, this is ridiculous. I agree. Particle service. Yeah, I didn't really change anything there. Added that to the header file. It's not really worth mentioning, and I already talked about this. Okay. Add basic rendering for particles. Okay, that's it. See, do people just see the high pay and think, oh, so easy? Yeah, that's what it used to be, right? If people saw the money, they're like, I'm going for it. What dreams am I hearing? Oh no. Alright, man. Well, hope you get your rest. I remember you said that was tough, but I still hope you get your rest. IKEA sell cookies? What? But yeah, man. Oh, I hope somehow you can get your sleep. Let this cat back in. Let's see. Oof. Yeah, I mean, I've had the restaurant before. What's wrong, kid? Okay. You just feel like screaming today? Okay. Be okay. Just lay down. I know it's cold. Yeah, I remember the like the horse meatballs they had from that restaurant. Pretty good. That's all I remember about IKEA though. Yeah, you didn't know? Or I don't know if they changed it, but back when I used to go to IKEA, they had the meatballs, they made a horse. Is that? Let me see. Let's see. IKEA meatballs. That also could just be like some factoid I heard from somebody and then I just ran with it. Horse meat found inside IKEA meatball. I've shown no traces of horse meat. Oh, okay. So I guess it was one of those, what are they called? One of those like lore things people would say. Horse meat found in IKEA. Yeah, there's a bunch of publications about it, but I guess it was just like a, it was like a meme. Yeah, hella meatballs, man. Yeah, you know what I'm talking about. Go get him, man. You gotta get him. You gotta tell him. They put in horse and meatballs. Oh my. Okay, did I finish the commit? I did. So, yeah, I gotta make sure I can get these scripts working with this. I wonder if that was done on purpose. That's funny. That would be hilarious. Okay. So scripts. Scripting, scripts. So, I already have the basic function definition. Let's see. Yeah, so this is the one I want to move over. Let me finish this though. So start time. Again, I was going to the engine to go check on that. Do I still have that up? I don't. Engine run. Engine run. High resolution clock. Yeah, there we go. I think this is in nanoseconds though. I don't know. This seems kind of like overkill, to be honest. And it's going to be new particle dot end time is equal to, and it's going to be start time. I don't know what I add. I gotta figure that out. Which is the same with chat. Also for 250 you get a couple with refills on the soft drink machine and one for the coffee machine. Ooh. Oh my. Okay, well, we can free come by whenever you feel like it. But yeah, get your rest, man. Oh, it's new particle. You didn't go for the what are they called? The suicide ones? What is that? The one where you take your cup and you go like straight through all the sodas. I forgot the name of that. I think it was like suicide something, but yeah, I used to mess up my stomach when I was a kid. Oh, crap. So I can set it. I gotta check the C++ standard really quick. Bro, what? Oh yeah, oh wait, is this thing still on? Yeah, it is, okay. Yo, Booty Boy, do you want to be a mental health fluffer? I got this right here. A little section in my on my engine repo. It's right here. A mental health fluffer. I'd love to make you an honorary one. You seem pretty chill. There we go. All right, I got you. I got you. Next time you log on. Actually, you know what? Let me see if I can do it real quick. How about you do this anyways? Let's see. Oh, hold on, I have an idea. Let me open up Twitch. I need some. How do I say? I need a little bit of a distraction from the particle code. Let's see. Let me open up my stream. Let's see if I can find you. There we go. I'm checking in the other screen, by the way. Let's see. Oh, it's not on there. Okay. All right. I'll put you in the list for now, and then maybe we'll get you an icon later. Let's see. Where is my README? Oh, you know what? I should probably open it up here. Let's close all these two. All right, here's README. All right, sit down at the bottom. Let's see how that looks. Wait, hold on. I gotta make it, let's try 3. Try that. No, hold on. I got something better. I gotta find you a image. Yeah. This one. There we go. It needs to be a PNG though. Let's try PNG. All right. So we're gonna do this one. Let's see. Let's paste it right here. Do this. All right. Alrighty. Image. Let's see. What is it? Text is here. Wait, let's go with this. There we go. We'll make it oh no. Wait. No. There we go. The boy, and let's make it white. There we go. Hell yeah. Corporate. Okay, image. Try this. Okay, we'll save this one. Let me check the resolution. Actually, let me do this. Hold on. Let me select this. Right about there. Image. Drop to selection. There we go. Image. Drop to selection. Okay. All right. And then. What are the properties of this one? Let's see. Okay, this is 300 by 139. Okay. So we'll get something similar. So let's take this right over here. Booty boy. 668. There we go. Let's open it up again. And then we're going to resize it. 300. Okay, so let's maintain aspect ratio. Let's do 300. Yeah, that's about there. There we go. That's you. And we in here. Okay, wait. Let's see. So if they're doing this. What is it? Pretty boy something. Or is that incorrect? Maybe my brain's not working. Image contributors. It might be alphanumerically. I just misspelled it. You said whatever that means. Yeah, I'm gonna go ahead and chill on that one. I could just put like in text. Hold up. There you go. That's wild though. That's crazy. You gotta have on your ID badge. You have to put like your ethnicity. Yeah, I'm gonna go ahead and chill on that one. All right. But Yeah, I forgot how you add space though. How do you add space? Let me do this. And then it goes below, right? Oh yeah, there we go. Yeah, that works. Alright, you are an honorary mental health fluffer, my guy. Hey, get that bread, that's why I say. Alright, honorary member. Let's go. Alright, back to the weenie grind. Chrono. High resolution clock. Okay, so yeah, what they're doing? Bro, I forgot. Something about the standard, I think. I was gonna see what, yeah, how do I do this? Let's check this. I don't know what units this thing uses. I think it's nanoseconds. Okay. So we get chrono, high resolution clock. And then we do that here. Then we do the diff. And the diff is what? Oh, okay. So I guess the time points aren't necessarily in any like unit of time. I guess you can just grab the duration and then like increment it, I guess. Wait. Hold on. You know what? We'll just do ChatGPT. I'm just gonna paste my code too. Let's see. Hey, I want to set the end time number to the start time plus the delay in this code. Also C++, because maybe, I don't know how it would get confused, but you know, sometimes it does. Let's see. Oh, is it really that easy? Wait, but it needs to be in milliseconds. Oh wait, did I just copy the... I did. I thought I meant this code. The provided time is in units of seconds. So no problem, you want to set, yep, so I have to do a conversion somewhere. Okay, let's see. So get now, convert the lifetime in seconds to a duration. Okay, and auto duration. Yeah, I'm not bothering auto. Auto hurts me. Let's see. So let's just do this. Good. Good. Let's go back and then go here. And let's not do auto, so do st chrono duration floats. The chrono duration floats. Okay. Right, and then what's wrong? Can't do the conversion. No assignment operator is equal to time points. Does it convert something or something? Oh, wait a second. Let's see. Is ChatGPT lying to me? Sometimes it does that. I always get confused by the chrono library, but I never feel like actually going and reading the full documentation. I don't know, I'm just lazy. Let me go look at it, I guess. Instead of just flailing around like this. Okay, so start, end, now. Elapsed time is end minus start. Sure. Yeah, I'm just confused. Let me see. SD chrono duration. Like, I get this. You can do like between time points, and then typically you set a time point. Maybe I keep doing this auto thing too. It's kind of annoying. Don't like that. Steady clock. Wall. Yep. Monoshock. Sure. Time points. Clock time conversion. Clock cast duration. Yeah, I'm actually not sure. Maybe you can't convert it like that. Let me try it. Let me try something. So start time again is a time point. Dot time since epoch. Yeah, I'm not worried about that. Max min plus duration. Is this, so what does this end up being? This assignment operator is going to return something. No operator time point matches these operons. SD chrono time points is equal to time points of duration float ratio. Let's just ask ChatGPT. Hey, what's wrong with this code? Or maybe, okay, let me go look at the constructor, or maybe the assignment operator for a steady clock. Maybe that'll give me a hint. Or high resolution clock. At the time point, actually. The constructor construct a new time point. Returns the time point as the duration. Okay, overloads the assignment operator. Time point is now. To time. Oh, do I have to do this to time t, maybe? Now minus 24 hours. And then this is using a chrono literal, so that's why that works. Okay. Is that what this is? Time point? SD time T. Time point is now. Time point. And these are the durations, yeah? This code is not compiling. What's up? Maybe I can give it more specific information, but whatever. Works with person clock, no. Works with particle class, remember let's go through view ones. Okay. So specifically the new, and let me just copy this. The is having trouble converting the R values on the left, on the right side of the operator, of the assignment operator. Into a time point. Add duration to what? Yeah. Okay, so I have to cast it to a nanosecond duration. Oh, okay, maybe the template arguments didn't match. That's probably why. Same type as the clock's duration. Float became, because the duration is agnostic of the type, but if you want to convert it back into a time point, you need to make it work with its value, I suppose. I don't know. ChatGPT could just be lying to me again. I don't know. Let's see. Hey, good job. Okay, cool. Nice. Okay, cool. All that just to get this working. Okay, let me push back the particle, and then we'll do a bunch of math with durations on the onUpdate function in a moment, but we'll leave that alone for now. All right, so let's get this working with scripting. Brain's getting a little tired. So let's go to the script service. All right, we'll scroll down and then we'll add this as a function. If it will load, there we go. Okay, let's come down to like here, I guess. Okay, here's where I usually add it. So this one's AI. This one's physics, I guess. It's spaced off a little bit. Scenes, transform components. Bunch of garbage. Let me put a space here. Okay, well I guess this is a new section, so I'll put it right here. Let's duplicate this. We'll do... Oh yeah, okay. I gotta be careful with this, because the names have to be different every time. Okay, so... Particle. And then we're going to say add particle. With location. Yeah. Yeah, because this one needs to be specific, but the actual in script name of it does not need to be specific. but this is just a limitation of dealing with C++ DLLs and crap. So it is what it is. Okay. So we're going to take in the particles, particle service, and add particle. I'm going to overload with the one that I want. Wait, it might be. Oh shoot, actually it might be ambiguous. Okay, that's kind of annoying. Is it ambiguous? I don't know. I'm gonna be right back though. I'm gonna use the restroom in like a few minutes.
Try to remember. But when everything is coming back to me, I feel as if my memory is paralyzed.
Now let's see.
the last thing you can remember?
I don't know.
Go on. Oh, wait a minute.
I was talking the whole time my mic was muted. Oh my. Damn. Alright, let's see. Raycast results vec2, huh? Alright, so I'm probably gonna need a new type for this. Where did I go? No, it's probably below this. Okay. So this one is, oh yeah, I gotta go here and then change this from a vec3 reference to just a vec3, which not the most efficient thing, but Honestly, I don't even know nowadays. All right. Okay. We pass in, and I guess we take it in by copying it. Sure. Okay, now let's get back to actually adding it. So, add particle location. So now this is going to be a void vec2 vec2. Oh no, vec2. What is the second part? Oops. Is that a thing already? I guess not. Yeah, I guess not. Okay, well, I guess I'll add it. So void vec2 floats. Sure, very good. Float. Yeah, okay. Also, these can come back a little bit if they want to, maybe not. Okay, this doesn't know what this is currently, that's fine. Oh, wait, I gotta copy this. Let me put this into my workspace really quick. It's gonna paste it over here. So it's a void vec2 vec2. Let's copy this whole thing over. Put it on my other screen for a second. Do 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 do. Alright, let's go to the top actually. Okay, I think that's good there. Lots of function pointers and whatnot. I think we want this one. Okay, so this will be the definition for the macro. I hate these macros, but pretty evil in this case. Floats. Okay. Okay, this is a 2-parameter one. Okay, I don't know where a good place for this is, so let's put it right here. This is going to be void math vec. Wait, no, it's a vec3. What am I doing? Floats. Just throwing in bugs just for fun. That's me. That's me. Particle. Okay, that's his name. Where'd it go? Here it is. Okay, so particle, add particle location. I gotta go back up and add it to vec3, not vec2. Void vec2 floats. Okay, so this is vec3 floats. Yeah, vec3. Wait, is vec3 float already a thing? Void vec3 float. Oh, okay, so this is there, sure. Alright, yeah, adding new scripts is always kind of annoying. But kind of a necessary evil in this case. I mean, maybe I can organize this a bit better. Okay, so here we're gonna do vec3 floats. There we go. Let's scroll down a bit. Oh, wait. Vec3 floats. Yeah, I think this was the one. I don't mess anything up by doing this. Yeah, okay. Void vec3 float. And then vec3 float, okay. And I believe this is a new type. So I always get kind of confused here. It's something like this. Void vec3 float. Okay, and then this one is going to be oh, it's this thing. Let me go copy it real quick and bring it over. Void vec3 float. Vec3. Yeah, it's here. Void vec3 float. Yep. AddParticleLocation. I think that's it. Okay, let's find all the AddParticleLocation. Do by AddParticleLocation. By. Is that it? Okay, I think I'm good. So that adds that. Oh no, wait. Cancel. Okay. Welcome back, booty boy. Welcome back. Let's see. Yeah, I think I'm getting close to done. I just want to get particles spawning and then evaporating. That's all I want done today. Let's see. Okay, so I think this is hooked up on this side. So now we should be able to access it through the script, through the C++ DLL. So now let's head over to the scripting compiler. Actually, maybe I shouldn't search for it like that. I'm just gonna look for it. All right, so scripting compiler service common compile script file. Bruh. Okay, here it is. Create KG script language definition. That's what I want. So in this case, we're going to add a function def. And it's just going to be like one of these. So let's look for a few things. Actually, the first thing is I probably have to add a new namespace. So we have for one for UI, game state, scenes, blah, 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 blah. Okay, we're going to add one for particles. Particles. This provides functions that interact with the particle system in the engine. Easy as that. And then these descriptions pop up when you hover for some text in the script editor. So that's nice. So we have the namespace now. That's good. Let's head back. All right, now let's add this actual function. Okay, let's scroll down really quick. Let's go find something similar. Something with multiple parameters. It's easy to set up. Yeah, I should probably turn this whole thing into a function. I think it might be a good idea. But you know what? I am not doing that right now, so I'm not going to bother. That is not my prerogative. Particles. Let's see. Particles. Okay. Add particle. That'll be the name of it. Easy as that. Return type none, of course, right? All types push back. For the parameter, the first one's a vector 3 or vector 2, so I don't know how I call that. Oh, it's okay, vector. I just call it like that. Okay. So this is a vector 3. Is that a primitive type? Yeah. Okay, then the identifier for it is going to be particle location. And the second one's going to be the float, which is the delta time. So we push the parameter. The second one's going to be a float. And it's going to be set display. No, it's going to be particle lifetime. There we go. New parameter. Okay, and let's add a description. Let's go ahead and duplicate this really quick. All right. Let's create a simple particle. At the specified point. This function takes in a vector 3 for the particle position and a float to delineate its lifetime. To indicates its lifetime. There we go. Okay, I think that's it. Alright, and then this is the onGenerate function, which just, yeah, I need to change the identifier to this, because this is the function we already actually set up. Okay. There we go. I don't think there should be any other issues with that. That adds the function, then we're good. Cool. Alright, so let's go ahead and load this in. We'll see if I broke everything. It's a possibility. And yeah, go from there. I do love the cat model. Alright, let's see. Please don't break. Okay, yeah, so this always happens. Could not load void vectory. Cat model is hype. It is hype. Yeah, apparently it's pretty common model actually, which makes sense because it's just like a basic model you get off of what's it called? It is a basic model you get from the VTuber app that I use. So there's a bunch of people being like, "Wait, are you trying to be this person?" And I'm like, I don't know who that is. Yeah, I don't know. Okay, what was I trying to do? Oh yeah, build the script module. So let's rebuild it. Hopefully it doesn't break. Okay, cool. So there we go. Let's see. Okay, so I mean, I could try to use it, I guess. I don't know. Okay, I think I have an idea. Let's do some stuff. So we're gonna go. I don't know if I have like a general OnUpdate function. That might be a good idea. Now that I think about it. I don't think I've ever had to actually bother with that type of thing. But that makes sense. Also, I look, you want to maybe have like a tree where the scene goes right here, and then this all kind of originates. So I added this user interface editor. That's what I've been working on recently, and this is kind of garbage at the moment. Yeah, text map is just broken. So annoying. But here, I have the actual like UI node, then you have the window node, and then you have the text node, right? But here, this is the UI, right? The central node. And you can make little changes here. Before I stuck all the changes right here, but I think it's better to just put it right here. That makes more sense, right? So I might do something similar to the scene, I was thinking. Yeah, anyways, I sidetracked. Let's see. The script editor inputs, game states, components, AI states. Okay, what about project? Is there like a general... Yeah, I guess I haven't had a need for like a general system. I will add that at some point. It'd be really nice to have like a system abstraction. Yeah, okay, well, I guess if not, let me find some place where I can put the OnUpdate into. Okay, you know what? I'm just gonna put it into one of these entities OnUpdate. Let's go with player 1. I don't know if I want to mess with... Okay, you know what? I'm gonna put a script here. So let's do... Oh yeah, I have to do that. Okay, so let's go to... Where's it? We're in level 1, right? Maybe I can add an entity here. Create entity, and I'm gonna call it testing entity, right? Because garbage. It has a translation. Yeah, I don't care, but yeah, it's like right here. Move this back a bit. Move it over here, I guess. Yeah, let's put it in the center. All right. Okay, and then for this entity, we're gonna add a component. We're gonna add an OnUpdate component. If I can find it. Oh, there it is. Which is actually kind of a lot now that I think about it. But whatever. Alright, so for the OnUpdate component, we're going to create a script. Provide this and this, sure. Doesn't really matter. We're just going to do test particles. Test particles. There we go. Alright. And yeah, we'll just create it at the root at the moment. I'll add better API to the scripts once I give it its own window. But yeah, we'll open this up. Okay. So first let's check if the particles is a thing. It is a thing. Add particles, cool. And then it says provide a particle location along with a lifetime. So that's cool. What is up with this description, man? I gotta fix that. So you don't write your own wrapping code. Okay. Simple with a vector 3 and then the position. Okay, so you know what I'm gonna do? I'm gonna do a random. Let's do random. Get integer. Okay, and I can do an upper and lower bound. So, I guess. Let's see. What should the upper lower bounds be? All right, so this one's positioned at 0 on the x-axis, and then this one is positioned at 50. Okay, so anything between, like, I'd say like 1 and 49, I guess. And then this will get the do I have an int? I know I have to specify the size, don't I? Okay, so I'll do uint 16, maybe 32. What does this return anyways? This returns a int 32. Okay. Do int 32. X. Location. Can I specify a float here? Is that gonna break or not? Maybe I should specify a get float. That might be a good idea. Yeah. Yeah, should I? I suppose. Okay, yeah, I guess I have to. Alright. Because it's going to be a vec too. That's going to take in 3 floats at the end of the day. So let's go and comment this out. And then I'll go ahead and add that to the API real quick. So go to the random section. Oh, nope, service. Okay. And actually, this should be as easy as just copying this over. Generate random number. I'll say generate random floats. And then we're going to do a floats. We're going to do a floats. And a float. Floats. In doubt, ask ChatGPT, I guess. That's what I say. I guess. Can you give me the code that gets a float? Random floats in this code. Oh, it's called real distribution. Okay, yeah. That's fine. And let's just do random integer. Just to be specific, I guess. Okay, and I believe this is compiled into the final DLL by default. So all I really need to do is just go to the language and just add the new function definition. I think maybe not. I don't know. Is it? Let me go check scripts really quick just to make sure. Service. Let's find no. Random. Oh, I do it here. Okay, it's kind of annoying. Random number. Integer. Alright, so let's do generate random number. And then we're going to place it with generate random integer. Okay, I guess that's it for this one. Nice. Just have to change the name. And then here, basically, we're just going to duplicate this. this right here, bring it back because I don't know, and then generate random floats. Okay, and I guess we're just going to float 3 times, sure. Floats. Wait, what's going on? Okay. Place floats, floats, floats. Alright, I have to add that everywhere. Where's the uint 3 times? Here it is. Floats, floats, floats. Capital. Also, floats, floats, floats. Copy this really quick. Alright, and let's scroll up. Let's go add this everywhere. And I gotta skip this for a second. Let me just zip up to the top. Alright, I don't know where to put it. I guess I'll just put it right here. Floats, floats, floats. Floats, floats, floats. Alright. Let's come down here. Yep. So same thing. Float, float, floats, 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 float. Alright. And then this one has 2 parameters. So we'll just put it right here, I guess. Is it going to matter? Actually, maybe it does. Where's random? Let's put it up here. Generate random floats. Floats, floats, floats. Alright. Where's the uint 3 times? There it is. Okay. Okay, there we go. Let's go down to here, and then yeah, should be good. Alright, so now let's head over to the language. So we'll go to script compiler service. Let's go down to create language def. And in the functions, we're going to find random. Okay, we just need to change this to integer. Okay. And then this just becomes a duplicate, essentially. And we're going to call this get float. Generate random floats. Note that this function uses a fairly expensive algorithm generating numbers. Yeah, I know. Pseudo-random. Compared to pseudo-random, this function takes 2 integers to note lower and upper bounds respectively. Yep. Yep. And then, of course, instead of doing a uint at int32, we're going to do a floats. Floats. And floats. Lower bound, upper bound still accurate. Okay, float. Okay, I think that's good actually. Let's try this. So now I should be able to generate a random float. That's good. Right, what I do? Generate random number is not a member of. I would agree with that, yeah. integer. Wait, it didn't change the name everywhere, I guess. Oh, okay. Okay, where else? Okay. Okay, float is not a thing. Yep, I would agree with that. Okay, hopefully it's not broken. Let's see. Okay, cool. It's not broken. Good. Let's run it. Make sure I didn't, because this thing does use random number generation with the AI. The UI is still broken. Still bothers me very much, but okay, cool. All right, let's go back to those test particles, and then this time let's get floats. So random get float. What about get integer? Okay, that's an integer. Let's make sure it wasn't broken. All right, now we're gonna do 1.0f to 49.0f. And then we'll duplicate this. We'll do y location. And then let's check the y bounds for this. So we have -16 to +16. Okay. So we'll do -15 to +15. All right. What is wrong? It takes in two upper. Wait, what? What are you talking about? I must have not cleared something in between the definition. Oh, it never got cleared. What? Okay, there we go. Yeah, this is why this needs to get cleaned up. This is ridiculous. That could happen. Yeah, when I come back and I clean up this whole script thing, take a good look at this API for specifying the language definition. It's a bit messy. Okay. Okay. Looks fine now. Looks fine now. Okay. Now let's add a particle. Nice. All right. So we're gonna do a path. Oh no, it's just a vector 3 in the bed. So vector 3. Particle location is equal to, and then we're going to do x location, y location, and I don't know, what's a good z location? This is at a z location of 0, so if I take this and move it closer to the camera, it's going plus, so put this back to 0. Okay, so we're gonna do, let's do like 0.1f. Okay, so do the particle location. And then let's do lag time like 1 second. Okay, so now this function is being called every frame for... Oh, I never saved the thing, right? Oh, me. Okay. New entity. Test entity. Okay, let's say that time. And then let's go ahead and add a component, do it on update. I'll go ahead and open the script. Let's do, what is this one called again? Test particles, test. There it is. All right. Okay, let's go ahead and save that. We'll rebuild the script modules to make sure. Failed to compile, it's not good. What will happen? Let's see. Go check the logs. Okay, looks fine here. Particle add particle location. Oh, yeah. Okay, I understand. So let's close that. I mistyped something. Location. Yeah, it's supposed to be by. There we go. Try that again. If this works, I'll be very happy, and I think I'll call it a day there. Let's see though. Okay, so let's rebuild. Let's see if it works this time. Okay, nice. Alright, so let's go ahead and test entities, still running this thing. Yep. Alright. Oh yeah, okay, so it is working, I think. It is working. I think it's making a lot of particles though. It's kind of a lot. But yeah, I know the issue. Let's go to the particle service. Kitty? Yeah, go out. Alright. There you go. Okay, so we actually have to place the particle. So OnRender, right? Yeah, we just specify a transform, a matrix transform. It's just an identity matrix, so that's why nothing's happening. So we need to actually, make it work. So in order to do that, let's go to somewhere I do something similar. I think runtime UI service. Let's go to the onRender function. Here we go. Yeah, I just want this part. Perfect. And then this is going to be particle dot and position, and we're golden. Oh, my bad. Okay, yeah, we're golden now. The only other thing is let's see. And this is not the most efficient thing, but this is all I got right now. we're going to copy and paste this. And then for particles in the particle pool, we'll say if particle dot, again, we're going to get the current time. So we're going to say yeah, we're going to grab a time point really quick. We'll say current time is equal to this. Okay. Okay, so we set the current time, and then we'll say if particle dot end time is greater than no. Hold on. If current time is greater than particle end time, isn't there like a, hold on. Is there a way to remove multiple indices from a vector at once? Multiple elements using indicated indices from a vector at once. I'll say an STT vector, so you know what I'm going to do with once. Sort the indices in descending order. Oh yeah, I remember this kind of remove the specified indices. Oh, I hear a cat crying again. From her. All right. Actually, yeah, this is an interesting problem. And I'm not sure what a good solution for it is, because we might have to remove elements that are... Oh, yeah, this is... Okay. Yeah, this actually is going to be an interesting algorithm problem. So I'm actually going to just go ahead and put it to you for this one. Because here's the thing, first rule of a for loop, never do credit create operations inside of a for loop. That breaks everything. So yeah, tons of problems with that. So we need to index the ones that go past this time frame, and then later here we need to go ahead and delete indicated particles, right? But the thing is, we're iterating through the vector, and while we're iterating through this vector, right, if we pull out particles at like random locations in the vector, we're gonna have big holes in the vector, and even if we keep pushing back, we're just making the buffer bigger. And then we're gonna end up with a whole bunch of holes in the front of the buffer and a bunch of wasted space, and nothing's gonna be contiguous. So that's gonna tank performance like crazy. So I need to figure out some way to keep the like the indices compact. And Yeah, there's a few ways to do that. It's just I'm trying to see what makes the most sense. So since that's the case, I'm gonna leave this alone for a bit and just spawn the particles and then just go from there, I guess. To do. Find data structure that works best for this use case. And I can kind of see now why the channel had the index for his thing. He's probably like storing the indices for where like certain particles go in certain places, and then he's caching the location so he can keep running through the indexes. Like he can index through the vector and then keep looping through the whole vector, and then like instead of just endlessly adding more elements, he loops after the maximum and just keeps circling around. I don't know if that keeps everything cache coherent, but at least doesn't balloon out the vector into infinity. Yeah, I don't know. But anyways, let's just see if the particles will spawn though, because the change I just made here with the translation should spawn the particles in random locations. It's going to look kind of crazy. So let's see. All right, let's try it. Yep. Yep. Okay. Yep, and it just keeps stacking. Tons and tons of particles. All right, let's stop it. And I think they save them, yeah, because it stays in the cache. Oh my gosh. All right, and then there's no way to clear it right now, so normally you would specify a lifetime and then they would just go away by themselves, but since I can't do that, they just don't go away. Yeah, I'm pretty sure if I look at like the runtime statistics, my my memory is gonna like shoot up right now. Well, I guess it won't shoot up. Yeah. Yeah, I guess it won't shoot up because each one is like how much memory? It's not even that much. Yeah, this is a vec3 plus a vec2 plus a float. That's basically two vec3s, which is 96 bits times 2, 180 bits. So divided by 8. 180 divided by 8. It's 20. That's 20 bytes per this thing. And you multiply by 100. Oh yeah. This is tiny. It's gonna take forever to start causing a huge memory leak. But the rendering is gonna go crazy. So, okay, I'm done. I'm done for today. I'm satisfied. I was able to spawn a bunch of particles. Just a bunch of squares, but whatever. Cool. Alright, let me go ahead and set up all this code and then commit, and I'm done for today. Rename random service, generate random number to generate random integer in random.h. Add generate random floats API to random.h. All right. AddParticleByLocation. That's cool. Yeah, I guess add location function to particle service.h and use particle location when rendering and particle service. That's easy. Okay. Script compiler. Okay, yeah. So then add functions to spawn a particle and generate a random float and script compiler service and script service in kg scripts. Okay. Add basic spawning of particles in what's it? Scripting language. All right, go ahead and commit that. And I think that's done. I'll push this later. Let me see what anything else I have to do. All right, so this is done. Did I change any game code? I did. Yeah, I guess I did. All right. I'll go ahead and push the Pong changes just in case I want to, I don't know, see the particle changes. So open terminal, let's go back one, and then we'll do get status. What is all this? I added a bunch of font files. And then added, okay, so it's commit -m, add extra fonts, and a particle script. Wait, didn't I? Okay, I don't know. Okay, there we go. I'll get push origin main. Yep. Pushing that up to the repository, and that looks updated. Nice. Okay. So engine code and game code has been pushed. I'm still at the same point I am in the progress board, so I think I think tomorrow I'm going to continue working on the particle system. I should be on tomorrow. If I'm not, I will indicate it on my schedule in the Twitch. Yeah, I'm just going to work on this until I can like properly mess with the system, but I'm not going to make it super robust. I can't really do like a full-fledged system until I start working with compute shaders. So for now, I'll just get to this somewhere where I'm like, okay, this is right? So let's see what else. Yep, talk about what the next stream would be. So yeah, I guess that's going to be it for now. If you're watching on Twitch right now, I appreciate you coming by. Hope you have a good day or night. If you're watching this on YouTube, hope you have a good day or night whenever you're watching this. And yeah, I think that's about it. So later.